Lean construction is a combination of operational research and practical development in design and construction with an adaptation of lean manufacturing principles and practices to the end-to-end design and construction process. Unlike manufacturing, construction is a project-based production process. Lean construction is concerned with the alignment and holistic pursuit of concurrent and continuous improvements in all dimensions of the built and natural environment: design, construction, activation, maintenance, salvaging, and recycling. This approach tries to manage and improve construction processes with minimum cost and maximum value by considering customer needs. The term lean construction was coined by the International Group for Lean Construction in its first meeting in 1993. The construction in lean construction refers to the entire industry and not the phase during which construction takes place. Thus, lean construction is for owners, architects, designers, engineering, constructors, suppliers. Historical development: Lori Koskela, in 1992, challenged the construction management community to consider the inadequacies of the time-cost-quality trade-off paradigm. Another paradigm-breaking anomaly was that observed by Ballard and Howell. Analysis of project plan failures indicated that normally only about 50% of the tasks on weekly work plans are completed by the end of the plan week, and that constructors could mitigate most of the problems through active management of variability, starting with the structuring of the project and continuing through its operation and improvement. Evidence from research and observations indicated that the conceptual models of construction management and the tools it utilizes fail to deliver projects on time, at budget, and at desired quality. With recurring negative experiences on projects, evidenced by endemic quality problems and rising litigation, it became evident that the governing principles of construction management needed revisiting. One comment published by the CMAA, in its 6th annual survey of owners, pointed to concern about work methods and the cost of waste. While the cost of steel and cement are making headlines, the less publicized failures in the management of construction projects can be disastrous. Listen carefully to the message in this comment. We are not talking about just materials, methods, equipment, or contract documents. We are talking about how we work to deliver successful capital projects and how we manage the costs of inefficiency. A new paradigm equals, Koskela argued that the mismatch between the conceptual models and observed reality underscored the lack of robustness in the existing constructs and signaled the need for a theory of production in construction. Koskela then used the ideal production system embodied in the Toyota production system to develop a more overarching production management paradigm for project-based production systems where production is conceptualized in three complementary ways, namely, as a transformation, as a flow, and as value generation. Transformation is the production of inputs into outputs. Flow can be defined as movement that is smooth and uninterrupted, as in the flow of work from one crew to the next or the flow of value at the pull of the customer. Value is what the customer is actually paying for the project to produce and install. Koskela and Howell also presented a review of existing management theory specifically as related to the planning, execution, and control paradigms in project-based production systems. Both conceptualizations provide a solid intellectual foundation of lean construction as evident from both research and practice. Recognizing that construction sites reflect prototypical behavior of complex and chaotic systems, especially in the flow of both material and information on and off-site, Bertelsen suggested that construction should be modeled using chaos and complex systems theory. Bertelsen specifically argued that construction could and should be understood in three complementary ways: as a project-based production process, as an industry that provides autonomous agents, as a social system. What is lean construction? Lean construction is a way to design production systems to minimize waste of materials, time, and effort in order to generate the maximum possible amount of value. Designing a production system to achieve the stated ends is only possible through the collaboration of all project participants at early stages of the project. This goes beyond the contractual arrangement of design-build or constructability reviews where contractors, and sometimes facility managers, merely react to designs instead of informing and influencing the design. Lean construction recognizes that desired ends affect the means to achieve these ends, and that available means will affect realized ends. Essentially, lean construction aims to embody the benefits of the master-builder concept. One can think of lean construction in a way similar to mesoeconomics. Lean construction draws upon the principles of project-level management and upon the principles that govern production-level management. Lean construction recognizes that any successful project undertaking will inevitably involve the interaction between project and production management. Lean construction supplements traditional construction management approaches with two critical and necessary dimensions for successful capital project delivery by requiring the deliberate consideration of material and information flow and value generation in a production system, and different project and production management paradigms. While lean construction is identical to lean production in spirit, it is different in how it was conceived as well as how it is practiced. There is a view that adaptation of lean manufacturing production forms the basis of lean construction. The view of Laurie Koskela, Greg Howell, and Glenn Ballard is very different, with the origin of lean construction arising mainly from the need for a production theory in construction and anomalies that were observed in the reliability of weekly production planning. Getting work to flow reliably and predictably on a construction site requires the impeccable alignment of the entire supply chain responsible for constructed facilities such that value is maximized and waste is minimized. With such a broad scope, it is fair to say that tools found in lean manufacturing and lean production, as practiced by Toyota and others, have been adapted to be used in the fulfillment of lean construction principles. TQM, SPC, Six Sigma, have all found their way into lean construction. Similarly, tools and methods found in other areas, such as in social science and business, are used where they are applicable. The tools and methods in construction management, such as CPM and work breakdown structure, etc., are also utilized in lean construction implementations. The three unique tools and methods that were specifically conceived for lean construction are the last planner system, target value design, and the lean project delivery system. If the tool, method, and/or technique will assist in fulfilling the aims of lean construction, it is considered a part of the toolkit available for use. A sampling of these tools includes BIM, A3, process design, off-site fabrication and JIT, value chain mapping, visual site. 5S, daily crew huddles. The common spirit flows from shared principles, whole system optimization through collaboration and systematic learning, continual improvement, pursuit of perfection involving everyone in the system, a focus on delivering the value desired by the owner and user, allowing value to flow by systematically eliminating obstacles to value creation and those parts of the process that create no value, creating pull production. The differences in detail flow from a recognition that construction is a project-based production where the product is generally a prototype. The priority for all construction work is to keep work flowing so that the crews are always productive installing product, reduce inventory of material and tools and reduce costs, while lean construction, a Euro 1 registered trademark, S main tool for making design and construction processes more predictable is the last planner system and derivatives of it. Other lean tools already proven in manufacturing have been adapted to the construction industry with equal success. These include 5S, Kanban, Kaizen events, quick setup changeover, poker yoke, visual control and 5Ys. Early involvement of contractors and suppliers. The early involvement contractors and suppliers is seen as a key differentiator for construction so-called best practice. While there are trademarked business processes, academics have also addressed related concepts such as early contractor involvement. Integrated project delivery Integrated project delivery is a registered business mark by Lean Construction Institute with the USPTO. Primary IPDT members include the architect, key technical consultants, general contractor and key subcontractors. Using IPD, project participants can overcome key organizational and contractual problems. The IPD approach to contracting aligns project objectives with the interests of key participants. IPD relies on participant selection, transparency and continuing dialogue. construction consumers might consider rethinking their contracting strategies to share more fully in the benefits. The IPD approach creates an organization with the ability to apply lean project delivery principles and practices. Equals commercial arrangements that support IPD and lean project delivery equals, there are at least 5 principal forms of contract that support lean construction. In America, IFOA uses explicit lean construction principles. Sutter Health in Sacramento developed integrated form of agreement for lean project delivery for use on healthcare projects in and around California. Consensus Docs 300 is a derivative of IFOA. Consensus Docs offers contracts on tri-party agreement for integrated project delivery, building information modeling addendum, and green building addendum projects. AIA Document C191 Unregistered Trademark Euro 2009 is a standard form multi-party agreement through which the owner, architect, contractor, etc. execute a single agreement for the design, construction and commissioning of a project. The American Institute of Architects provides a list of integrated project delivery system distributors. In the UK, PPC 2000 is publicised by the Association of Consultant Architects. In Australia, the Lean Construction Institute has collaborated with the Alliancing Association of Australasia around the topics of alliancing agreements and collaborative contracts. Other papers explain integrated project delivery and IFOA. PPC 2000, IFOA and alliancing agreements were among the topics discussed at the Lean in the Public Sector conference held in 2009. Integrated Lean Project Delivery equals, Integrated Lean Project Delivery is a process trademarked by the Bolt Group. It was created and is practiced by the Bolt Group subsidiary, the Bolt Company. The process aims to eliminate waste across the construction value chain, through evaluation of initial planning and design, and examination of construction processes to predict where and when waste will occur, which is then eliminated through the use of lean tools and the IPD process. An ILPD contract is a multi-party agreement that specifies the use of lean practices as conceived in the lean project delivery system. This distinction is needed because integrated project delivery is now only referring to the multi-party agreement regardless of what practices are used, the so-called IPD Light or IPD-ish. Practical applications of lean construction. In the UK, a major R&D project, Building Down Barriers, was launched in 1997 to adapt the Toyota production system for use in the construction sector. The resulting supply chain management toolset was tested and refined on 2 pilot projects, and the comprehensive and detailed process-based toolset was published in 2000 as the Building Down Barriers Handbook of Supply Chain Management, The Essentials. The project demonstrated very clearly that lean thinking would only deliver major performance improvements if the construction sector learned from the extensive experience of other business sectors. Lean thinking must become the way that all the firms in the design and construction supply chain cooperate with each other at a strategic level that overarches individual projects. In the aerospace sector, these long-term supply-side relationships are called a virtual company. In other business sectors they are called an extended lean enterprise. The UK Building Down Barriers Handbook of Supply Chain Management, The Essentials, states that the commercial core of supply chain management is setting up long-term relationships based on improving the value of what the supply chain delivers, improving quality and reducing underlying costs through taking out waste and inefficiency. This is the opposite of business as usual in the construction sector, where people do things on project after project in the same old inefficient ways, forcing each other to give up profits and overhead recovery in order to deliver at what seems the market price. What results is a fight over who keeps any of the meager margins that result from each project, or attempts to recoup negative margins through claims, the last thing that receives time or energy in this desperate, project-by-project gladiatorial battle for survival as consideration of how to reduce underlying costs or improve quality. Last Planner System. The Last Planner System, as developed by the Lean Construction Institute, is the collaborative, commitment-based planning system that integrates should-can-will-did planning with constraint analysis, weekly work planning based upon reliable promises, and learning based upon analysis of PPC and reasons for variance. Users such as owners, clients or construction companies, can use LPS to achieve better performance in design and construction through increased schedule program predictability. LPS is a system of interrelated elements, and full benefits come when all are implemented together. It is based on simple paper forms, so it can be administered using post-it notes, paper, pencil, eraser and photocopier. A spreadsheet can help. LPS begins with collaborative scheduling programming engaging the main project suppliers from the start. Risk analysis ensures that float is built and where it will best protect program integrity and predictability. Where appropriate, the process can be used for program compression too. In this way, one constructor took 6 weeks out of an 18-week program for the construction of a 40-bed hotel. Benefits to the client are enormous. Figure 1. Intense discussion during a program compression workshop. Before work starts, team leaders make tasks ready so that when work should be done, it can be. Why put work into production if a prerequisite is missing? This make-ready process continues throughout the project. Figure 2. Part of a make-ready form for documenting the process of making tasks ready. There is a weekly work planning meeting involving all the last planners, design team leaders and/or trade supervisors on site. It is in every ENEA registered trademark's interest to explore interdependencies between tasks and prevent colleagues from overcommitting. Figure 3. Part of a weekly work plan form used by trade foremen on site or design team leaders to prepare for the WWP meeting. This weekly work planning processes is built around promises. The agreed program defines when tasks should be done and acts as a request to the supplier to do that task. The last planners only promise once they have clarified the conditions of satisfaction and are clear that the task can be done. Figure 4. The promise cycle. Once the task is complete, the last planner responsible declares completion so that site management or the next trade can assure themselves that it is complete to an appropriate standard. A key measure of the success of the last planner system is PPC. This measures the percentage of promises completed on time. As PPC increases, project productivity and profitability increase, with step changes at around 70% and 85%. This score is measured site-wide and displayed around the site. Weekly measures are used by the project and by individual suppliers as the basis for learning how to improve the predictability of the work program and hence the PPC scores. A key part of the continual improvement process is a study of the reasons why tasks promised in the WWP are delivered late. The following chart shows typical reasons. Figure 5, example of a reasons Pareto chart. Recording the reasons in a Pareto chart like the one above makes it easy to see where attention is most likely to yield the most results. Using tools like 5-why analysis and cause-effect diagrams will help the team understand how they can improve the clarity of information and ensure that there are sufficient operatives. Last planner benefits only unregistered trademark T-stop at project predictability, profit and productivity. It contributes to positive changes in other industry KPIs. Danish research shows almost half the accidents and up to 70% less sickness absence on LPS-managed sites. LCI retains a registered trademark on the term and copyright in the idea and materials to prevent people who misunderstand or misrepresent the system from using it in trade. Consulting companies or individuals wishing to use the last planner system in trade must first be approved by LCI. Consultants are expected to make financial and other contributions to LCI in recognition of the work and effort LCI put into developing Last Planner. Last Planner system development continues under the direction of Lean Construction Institute directors Professor Glenn Ballard and Greg Howell with support from users around the world. For more information about the development process, see Ballard and Howell for example. For a detailed description and list of the benefits of LPS, see Mossman, Last Planner, a registered trademark. 5+1 Crucial and collaborative conversations for predictable design and construction delivery. Differences between LC and project management approaches. There are many differences between the Lean Construction approach and the Project Management Institute approach to construction. These include, managing the interaction between activities and combined effects of dependence and variation, is a first concern in lean construction because their interactions highly affects the time and cost of projects. In comparison, these interactions are not considered in PMI. In lean construction, optimization efforts focus on making workflow reliable. In contrast, PMI focuses on improving productivity of each activity, which can make errors and reducing quality and result in rework. The project is structured and managed as a value-generating process, while PMI considers less cost as value. In the lean approach, downstream stakeholders are involved in front-end planning and design through cross-functional teams. PMI does na Euro unregistered trademark T consider this issue. In lean construction, project control has the job of execution, whereas control in PMI method relies on variance detection after the fact. In the lean approach, pull techniques govern the flow of information and materials, from upstream to downstream. With PMI, push techniques govern the release of information and materials. Capacity and inventory are adjusted to absorb variation. Feedback loops, included at every level, help ensure minimal inventories and rapid system response. In comparison, PMI does na Euro unregistered trademark T consider adjustments. Lean construction tries to mitigate variation in every aspect and manage the remaining variation, while PMI does na Euro unregistered trademark T consider variation mitigation and management. Lean approach tries to make continuous improvements in the process, workflows and product, whereas PMI approach does na Euro unregistered trademark T paid that much attention to continuous improvement. In lean construction, decision-making is distributed in design production control systems. By comparison, in PMI decision-making is centered to one manager sometimes. Lean construction tries to increase transparency between the stakeholders, managers and laborers, in order to know the impact of their work on the whole project. On the other hand, PMI does na Euro unregistered trademark T consider transparency in its methods. In lean construction, a buffer of sound assignments is maintained for each GRU or production unit. In contrast, PMI method does na Euro unregistered trademark T consider a backlog for GRUs. Lean construction is developing new forms of commercial contracts to give incentives to suppliers for reliable workflow and optimization at the deliverable to the client level. While PMI does na Euro unregistered trademark T have such policy, lean construction production system design resists the tendency toward local sub-optimization. However, PMI persists on optimizing each activity. The PMI-driven approach only considers managing a project at the macro level. This is necessary but not sufficient for the success of projects. Lean construction encompasses project and production management, and formally recognizes that any successful project undertaking will inevitably involve the interaction between project and production management. LC networks, research and teaching. Various networks and institutes conduct research and teach lean construction. Networks, journal and conferences. The Lean Construction Institute conducts research and industry outreach activities. There are national lean construction institutes in Australia, Chile, Denmark, Finland, Germany, Norway, and the UK. Articles in the Lean Construction Journal are available for free, under a Creative Commons license, and go back to 2004. Readers are referred to the Lean Construction Institute. The International Group for Lean Construction, founded in 1993, has conference papers available. The 2015 IGLC Annual Conference is to be held in Australia, in July. A list of groups in the global lean construction community is available via Dropbox. University research and teaching. Various universities teach and conduct research on lean construction. The Project Production Systems Laboratory at the University of California, Berkeley deploys tools to manage project production systems. The Construction Industry Research, at Michigan State University, investigates and develops construction processes guided by lean construction principles. A the Centre for Lean Projects, Nottingham Trent University, universities active in LC research and teaching, U.S. Illinois Institute of Technology. UC Berkeley. Michigan State University. San Diego State University, Texas A&M, Washington State University, Virginia Tech, Arizona State University, Purdue University, Bowling Green University, North Carolina State University, University of Texas Austin, University of Colorado Boulder, University of Wisconsin Madison, UK, University of Huddersfield, Nottingham Trent University, University of Edinburgh, Heriot-Watt University, University of Manchester, Salford University, Chile, Centro de Excelencia en Gestión de Producción en GEPUC, Pontificia Universidad Católica de Chile GEPUC Chile, Spain, Universidad Politécnica de Valencia IGLC 2014, Colombia, University of Los Andes, Research Group of Engineering and Construction Management CN2 Company, Israel, Technion Israel Institute of Technology, India, Indian Institute of Technology Madras. Global Initiative In 2009 Alan Mossman proposed a global Masters by Action research to be delivered by collaborating universities. The Lean Construction Lighthouse has sample course materials. History of firsts In 2002, the Lean Construction Principles and Methods Program CMP 831 was first delivered by Tariq Abdulhamid, at Michigan State University. It was the first full graduate program in Lean Construction as a named course. In 2000, PhDs in Lean Construction were awarded to Dr. Glenn Ballard, Dr. Lori Koskela. Around 1997, the University of California, Berkeley, became the first university to offer Lean Construction modules within its existing graduate offering. References. Bibliography, Abdulhamid. Lean Construction Principles. Graduate class offering at Michigan State University. http www.slideshare.net Lean Construction Introduction, Abdulhamid, T. S.A. The Self-Destruction and Renewal of Lean Construction Theory, a Prediction from Boyd Unregistered Trademark STHEA Proceedings of the 12th Annual Conference of the International Group for Lean Construction, 3rd to 6th August 2004, Helsingør, Denmark. Abdulhamid, T.S., El-Ghafi, M., and Salem, OE Lean Construction, Fundamentals and Principles American Professional Constructor Journal. Ballard, G. and Howell, GA Implementing Lean Construction, Stabilizing Workflow Proceedings of the Second Annual Meeting of the International Group for Lean Construction, Santiago, Chile. Ballard, G. and Howell, GA Implementing Lean Construction, Improving Performance Behind the Shield Proceedings of the Second Annual Meeting of the International Group for Lean Construction, Santiago, Chile. Ballard, G. and Howell, GA Shielding Production, Essential Step in Production Control Journal of Construction Engineering and Project Management, Volume 124, Number 1, pages 11 17. Ballard, Glenn. Howell, Gregory. Competing Construction Management Paradigms. Proceedings of the 2003 ASCE Construction Research Congress. Honolulu, Hawaii. Retrieved March 31, 2013. Ballard, Glenn. The Last Planner. Northern California Construction Institute's Spring Conference. Monterey, California, Lean Construction Institute. Retrieved March 31, 2013. Ballard, Glenn. Last Planner Ascent System of Production Control. UK, University of Birmingham. Retrieved March 29, 2013. Ballard, Glenn. OE Lean Project Delivery Systems LCI White Paper 8, Bertelsen, SA OE Complexity Construction in a New Perspective Proceedings of the 11th Annual Meeting of the International Group for Lean Construction, Blacksburg, Virginia, USA. Bertelsen, SA OE Construction as a Complex System Proceedings of the 11th Annual Meeting of the International Group for Lean Construction, Blacksburg, Virginia. Bertzelin, S. and Koskela, LA Euro OE managing the three aspects of production in construction. A Euro proceedings of the 10th Conference of the International Group for Lean Construction, Gramado, Brazil, August 6. A Euro 8. Kane, CTISBN 0-415-28965-3. Building Down Barriers: A Guide to Construction Best Practice. A simple guidebook explaining supply chain management and lean thinking, primarily aimed at the demand-side client. Kane, CT Performance Measurement for Construction Profitability. ISBN 1-4051-1462-2. A detailed action learning guidebook aimed at supply-side construction firms explaining why performance measurement is the key to lean construction. Kane, CTISBN 1-4051-1086-4. Profitable Partnering for Lean Construction. A detailed action learning guidebook that explains how to set up the extended lean enterprises that are the essential first step towards lean construction. The book provides case history evidence that the approach advocated can deliver savings of over 30% and explains what clients need to do differently in order to enable lean construction to flourish. FMICMAA 6th Annual Survey of Owners. Construction Management Association of America. Retrieved March 31, 2013. Gleason, F. and Town J. Lean Construction in the Corporate World of the UK Construction Industry, University of Manchester, School of Mechanical, Aerospace, Civil and Construction Engineering. Howell, Gregory A. What is Lean Construction? Proceedings IGLC 7. Lean Construction Institute pages 1 €10. Retrieved March 31, 2013. Koskela, L. Application of the New Production Philosophy to Construction. Technical Report No. 72, Center for Integrated Facility Engineering, Department of Civil Engineering, Stanford University, California. www.landconstruction.org. Koskela TR 72 PDF March 10, 2007, Koskela, Laurie. An Exploration Towards a Production Theory and Its Application to Construction. Finland, VTT Technical Research Center of Finland. Retrieved March 29, 2013. Koskela, L. and Howell, G. A Euro OE. The underlying theory of project management is obsolete. A Euro Proceedings of the PMI Research Conference, 2002, pg 293-302. Koskela, L. Howell, G. Ballard, G. Tomeline, I. Foundations of Lean Construction. In Best, Rick. De Valence, Gerard. Design and Construction, Building in Value. Oxford, UK, Butterworth Heinemann, Elsevier. ISBN 0750651490. Kuhn, T.S. The Structure of Scientific Revolutions. University of Chicago Press. Leitig, W. 10 Key Decisions to a Successful Construction Project. American Bar Association, Forum on the Construction Industry, September 29, €30, 2005, Toronto, Canada. Mastrani, R. and Abdulhamid, TSA Euro OE. The Challenge, The Impetus for Change to Lean Project Delivery. A Euro. Proceedings of the 11th Annual Conference for Lean Construction, 22 €, July 24, 2003, Blacksburg, Virginia, 610-621. Matthews, Owen. Howell, Gregory. Integrated Project Delivery: An Example of Relational Contracting. Lean Construction 2, 46 €61. ISSN 1555-1369. Retrieved March 29, 2013. Mossman, Alan. Last Planner: A Registered Trademark. 5+1 Crucial and Collaborative Conversations for Predictable Design and Construction Delivery. 35 pp. Owen Matthews, Gregory A. Howell, and Panagiotis Mitropoulos. Aligning the Lean Organization, a Contractual Approach. A Euro. Proceedings of the 11th Conference of the International Group for Lean Construction, Blacksburg, Virginia, 22 €, July 24, 2003. Salem, O. Solomon, J. Gennady, A. Lugering, M. Site Implementation and Assessment of Lean Construction Techniques. Lean Construction 2, 1 Euro 21. ISSN 1555-1369. Retrieved March 29, 2013. Solwoods, Dennis. 5 S's that would make any CEO happy. Contractor Magazine. Retrieved March 31, 2013. External links, Glossary Lean Construction Institute. http://www.lanconstruction.org. Dirks Mossman Last Planner.